What role does the balance between achieving a higher capacity and maintaining cycle stability play in the practical applications of sodium-ion batteries, and how can these trade-offs be optimized through careful control of the voltage range? How might future research efforts be directed toward identifying methods to mitigate the adverse effects on reversible capacity and cycle stability when operating at voltages higher than 3.5 V? And what experimental strategies could be used to explore this relationship further? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? When taking into account the performance of alpha-NaFeO2 under these varying voltage conditions, what additional questions arise about the limitations of current electrode materials? And how might these insights influence the design of next-generation cathode materials for sodium-ion batteries? What does the XRD spectrum reveal about the crystal structure of alpha-NaFeO2? And how can we interpret its characteristic peaks to confirm the phase purity and crystallinity of the material? How does the diffraction pattern help in determining the lattice parameters in space group? And what specific reflections indicate that alpha-NaFeO2 crystallizes in a trigonal structure, possibly within the R3M group? In what ways can the analysis of interplanar spacings and peak intensities offer insight into the symmetry and arrangement of atoms within the crystal lattice? And how might these features correlate with the material's performance in practical applications? How does the presence or absence of additional peaks in the XRD spectrum serve as an indicator of potential secondary phases or defects? And what further experimental techniques could complement this analysis to provide a more comprehensive understanding of the material's structural integrity? What challenges might arise when extracting detailed structural information from the XRD data of alpha-NaFeO2, and how can these challenges be addressed to ensure accurate phase identification and quantification? How does the confirmed crystal structure from the XRD spectrum influence our understanding of the electronic and ionic pathways in the material, possibly affecting its behavior as a cathode in sodium-ion batteries? And what further modifications in synthesis methods could be explored based on this structural information? Finally, how do the insights gained from the XRD spectrum of alpha-NaFeO2 contribute to optimizing its design and performance? And in what ways might future research build upon these findings to enhance the overall durability and efficiency of sodium-ion battery systems? What causes the battery capacity to decrease when this electrode undergoes an irreversible phase change? And how exactly does this phase change impact the matrix structure of the material? What?